Now let's have a look at how to name alkyl halides. Basically, naming alkyl halides or alcohols or amines, we will always follow the same rule of naming organic compounds, like the rules we applied for naming alkanes. But let's first talk about these classes one by one. So for alkyl halide, generally speaking, there are two ways of naming alkyl halides. The first way is to take the alkyl group as the parent name and then consider this halide group as a substituent. So for example, when you have something like this one, CH3OH, we can call this, sorry, CH3Cl. Sorry, I'm talking about alkyl halide. So if we have CH3Cl, then we can say it's chloromethane. We can call it chloromethane. So this is the first way of naming, where you name it based on as the alkane is the parent name and the chloride here is just a substituent. Another way is to take it the other way around, where we consider the methyl group as a substituent or as an alkyl group, and then we consider the parent name as the halide itself. So we will call this methyl. Another way of calling it, it can be called methyl chloride. So this is one way of naming these kind of compounds. Another way of another example of that, if we have something like this, CH3, CH2, Br. So we can either call this bromo, ethane, or we can call it ethyl bromide. When the halide is an it's a substituent. We call it bromo, chloro, fluoro, iodo. But when we take it as the parent name, we put it at the end, we put the sign ide. So it's methyl bromide, chloride, iodide, fluoride. Okay, so don't be mixed up between these two. We can do it either way. But this is the when we put it as bromide or chloride as a parent name, when it's a simple compound that doesn't have so many substituents. But what if we have something like this compound, for example, here? It has three different substituents. It has a two methyl groups, and it has a bromo as well. So then we will consider the longest chain of alkyl or of carbon chain as the parent name now. So we're going to follow the same rules we applied before. So you have to look at the longest chain of carbon atoms. This is going to be the parent name. So this one has seven carbon atoms, so it's going to be heptane. This is the parent name that will come at the end, or the root name of the compound. And then let's look at the substituents. We have two methyl groups and one bromo. So again, we need to consider which end we will start numbering the series we have, or the long chain we have. We will always have to number the long chain from the side that will give the substituent the lowest possible number in total. Okay, so for this compound here, we started numbering from the left, because then when we number from the left, we're going to have 2, 4 methyl and 5 bromo. 2, 4 dimethyl. So the methyl groups are on carbon number 2 and carbon number 4. So it's 2, 4, sorry, 2, 3, 2, 4 dimethyl and 5 bromo. If you number it from the other side, so let's have a look if we did number it from the other side, how it's going to look like. So let's say if we started off from here, it's going to be 1, 2, 3, 4, 5, 6, and 7. Then you will see that there is 3 bromo, and then 4, 6 dimethyl heptane. If you notice that 2, 4, and 5 is better than 3, 4, and 6. So this is why we are numbering it from the left, not from the right. So always remember to start numbering from the position that will give your substituent the lowest possible number. Again, when we arrange the different substituents in the name, we will arrange them alphabetically and completely ignore the prefix di or tri or anything because it just refers to the number. So I'm looking at the substituent name. So it's bromo, 5-bromo, and then 2,4-dimethylheptane. The other compound here on the right, this one, again, we're going to do the same. So we start numbering from the left. Now we have the bromo on position number 2, and we have two methyl groups, one in position number 4 and one in position number 5. So it's 2-bromo, 4,5-dimethylheptane. Some examples of that, as we said, we can name the alkyl halide by saying the name of the halide at the end, and we say "ide," or we can say it as a substituent. So something like CH3I, it can be called iodomethane, or we can call it methyl iodide. Something like this, it's a propyl group, or it's isopropyl group now. We call it isopropyl because the chloro is attached to the carbon in the middle. So we can either call this 2-chloropropane because now you have a propane as the parent name. So it's 1, 2, 3, and the chloro is attached to carbon number 2. So we can call it 2-chloropropane, or we can call it isopropyl chloride. Isopropyl chloride, the word iso here refers to which carbon the chloride is attached to. Iso means the carbon in the middle. So because propyl chloride means that the chloride is attached to the carbon number 1 or the carbon at the periphery. Another example is the bromocyclohexane. So you have a cyclohexane, this is the parent name, and then the bromo group is attached to it. So it's called bromohexane. Now it doesn't matter because whenever we number, we will always start numbering from this carbon that has the bromo attached to it. So it doesn't really matter. We don't need to say 1-bromocyclohexane unless we have other substituents. So we just say bromocyclohexane, or we can call it cyclohexyl bromide. So we take the bromide as the parent name, and then we took the cyclohexyl as just an alkyl group or as a substituent. There is another example here, so something like this compound now. So again, let's look at the longest chain of carbon atom. The longest chain has 5 carbon atoms. We have the bromo group attached to carbon number 1. We have chloro attached to carbon number 3, and then we have the methyl group attached to carbon number 4. We cannot call this bromide or chloride, but because we have two different halides attached to it, so we're going to take the parent name to be the alkyl chain itself, and we're going to give them the numbers. So 1-bromo, 3-chloro, and 4-methyl. Again, we put the bromo first because of the alphabetical order. So 1-bromo, 3-chloro, 4-methylheptane. There are some alkyl halides that they have common names and they are widely used. We normally don't call them with their IUPAC name, but or the IUPAC system of naming compounds, but we use the common names. And you should be familiar with the structure of these alkyl halides because in your practicals even you're gonna deal with some of these alkyl halides. Some of these are used as solvents, and you will always find that they are called with their common names. Examples of these are chloroform. So chloroform is a carbon that has 3 chloride groups. So it's here 3 chloro derivatives on the same carbon and the hydrogen. This is called chloroform. So it's basically CHCl3. This is chloroform. Carbon tetrachloride is a carbon with 4 chloro groups. So it's CCl4, so carbon tetrachloride. Methylene chloride. Methylene chloride here, methylene refers to a carbon that has 2 hydrogens, and then chloride, it has 2 chloro. If you notice now, we didn't say dichloro methane. It should be called dichloromethane if I'm calling it according to the UBAC naming, but the common name is called methylene chloride. So although we only said chloride, we didn't say dichloro or dichloride. This is the common name. So you should know when you hear the word methylene chloride that it's a carbon with 2 hydrogens and 2 chloro groups or 2 chloride groups. Methyl iodide, we've seen that before. So methyl iodide is a carbon with 3 hydrogen and 1 iodide group. There is also the trichloroethylene. Trichloroethylene is an ethylene, C double bond C, and there are 3 chloro groups here and 1 hydrogen. So it's basically CHCl, and then double bond. The double bond here as attached to the carbon refers to the double bond with the carbon, not with the chlor, and then CCl2. Okay, so the double bond here between carbon and carbon, even when I write it this way, it doesn't mean that the double bond is between the chloride and the carbon. The double bond is still between the carbon and carbon. You can also write it this way, Cl, HC, double bond CCl2. So this is called trichloroethylene. For alcohols, how to name alcohols? So again, we select the longest carbon chain containing the hydroxyl group. And then the derived name we will take the parent name of the alkyl group, but instead of saying heptane, methane, ethane, so we'll take the E off and then replace it with an OL. Let's have an example for that. So for example, CH3 OH. Okay, so we know that the parent is methane, so now this is going to be called methanol. So we replace the E in methane with an OL. So this is how we call our alcohols. Um, let's look at some examples. So if we have other substituents, then we're going to deal with it normally. We're going to start off by numbering the carbons in the longest chain. So this is 1, 2, 3, 4, 5. Okay, so this is going to be called pentane. And then we look at the hydroxyl group. What is the hydroxyl group? It's on carbon number 2. So because we have a hydroxyl group, we're going to add the suffix ol at the end instead of the E in pentane. And then don't forget to put the number of the OL or the number or where the hydroxyl group is. So it's on carbon number 2. It's very important. If you don't say 2, then that means that the OH on carbon number 1. So if the OH is in carbon number 1, you don't have to say 1, but if it's in any other position other than 1, you have to say where is it exactly. Now we have a substituent as well. We have a methyl group on carbon number 2, so it's going to be 2-methyl and 2-pentanol. So this is how we name this one. Let's have a look at this one. So now where is the longest carbon chain? This is the longest here, 4 carbons. We numbered it 1, 2, 3, 4. We always try to number it to give the OH, which is the functional group, the smallest possible number. Okay, so now the OH is on carbon number 2. And let's look at the substituents. So we have this phenyl group, an aromatic group on carbon number 3. So it's going to be 3-phenyl and 2-butanol. 2 because the hydroxyl group is on carbon number 2. Butan because it's 4 carbon atom in a chain, so it's a butane. So you replace the E with an OL, so it becomes 2-butanol. What about if we have 2 OH groups? How are we going to name it? The same way when we did have when we have 2 of anything, we say di. So now the di will come before all. So it's going to be diol. So something like that. So it's a cyclohexane. Okay. Ignore the cis and trans now because this is out of the scope of what we are talking about now. So we will just, we're not considering the stereochemistry here, whether it cis or trans. We just focus now on the substituents. So it's cyclohexane, and then we have 2 OH group, 2 which we will call diol, and we have to say where exactly are they. So they are on carbon number 1 and carbon number 4. So it's 1,4-cyclohexane diol. And 1,4 here refers to the diol. So you have to specify exactly where are they. Now, as I told you before, if you don't say, if the OH is in carbon number 1, you don't have to say that it's on carbon number 1. But when you have 2 different OH group, you have to specify even if it's one of them is on carbon number 1. It has to be on carbon number 1 on something like cyclohexane, because we will always start numbering for cyclohexane from the carbon that has a OH group or that has that functional group. So although one of these two OH groups are on carbon number 1, we're still going to say 1 for cyclohexane diol. You can also put this number before the diol. So example, you can say cyclohexane and then you say 1,4-diol. It's the same. So either you put it in the beginning or you put it just before the diol. They are all exactly the same. Again, here for this one, you can say 3-phenyl butane 2-ol. So it's also the same name. So you can either put the number before the suffix ol, or you can put it before the whole parent name of the alkane with an ol at the end. Again, many alcohols have common names, like we talked about alkyl halides. Some of these, I'm sure you are very familiar with many of these names, even if you don't exactly know how they look like or what are the structure of these ones. The most common ones that you are going to deal with in your study generally are ethylene chloride, ethylene glycol. So ethylene glycol is basically CH2, CH2, and for each carbon there is an OH. So it's basically 1,2 dihydroxy ethane or 1,2 ethane diol. So it's 1,2 ethane diol. If you are considering the OH, by the way, as a general substituents like other substituents, and it's not the parent name, if you have another functional group that's going to be a parent name, you will call this hydroxy. So if you have an OH in a big compound and it's not the parent name, the hydroxyl group is not the parent name, we will call it hydroxy. Okay, but if it's the parent name, if this is the main functional group in your compound, then we will call it ol. We said here ethane diol because we have two hydroxyl groups. So this is ethylene glycol. It's two hydroxyl group attached to the two carbon of ethane. We have glycerol. We all know what is glycerol. Glycerol. So glycerol basically is a propane, and there is an OH group attached to each of the three carbons. So this is called glycerol. We can call it 1,2,3 propane triol. Tri here because there are three. So, and we have to specify it's 1,2,3 because you may have two OH group on the same carbon. So we have to specify it's 1, 2, and 3. And by the way, these are accepted, these names are accepted by EUBAC. So if you call ethylene glycol, you're still following the EUBAC naming system for this particular compound because they are accepted by the EUBAC. Benzyl alcohol, when you have, this is called a benzyl group as a whole. So we call this benzyl alcohol. Or we can call it phenyl methanol. So phenyl methanol, because methanol or methyl group or methane only has one carbon. So I don't have to say one and one because there is no two. So if the methane is the parent name, then it's going to be, has two substituents. One of them is phenyl, one of them is the ol or the hydroxyl. So it can be called phenyl methanol. This group is called allyl. Allyl is basically a propene and an OH attached to the carbon number 3 in the propene. Okay, so when you have an alkene and an OH, then the OH will be given priority in the naming. So when you number this propene, you're not going to start with the carbon with the double bond, but you will start with the carbon with the OH. So it's going to be 1, 2, 3. So it's basically two propene because the double bond on carbon number 2, 1 ol. Or we can call it allyl alcohol. This is the common name because this group as a whole is called allyl. Finally, there is the tertiary butyl alcohol. This is a tertiary alcohol, as we can see. Tertiary alcohol, where the carbon here is attached to three groups. This is called a tertiary alkyl alcohol. We can, if we are to name it using the EUBAC system, then it's one, the longest chain has three carbons, 1, 2, 3, and then the OH is on carbon number 2, so it's a propane, so it's 2-propanol, and then we have a methyl group on carbon number 2, so it's 2-methyl-2-propanol. And when you see the name tertiary butyl alcohol, you need to know that it's a carbon with 3-methyl group and an OH. So this is called tertiary butyl alcohol. It's a very common name for this alcohol, this tertiary alcohol, and you will encounter this a lot in your study, especially when you work in the lab. Will you see that there is an alcohol that you may use as a solvent that's called tertiary butyl alcohol. So what about amines? So with amines, we use the suffix amine. So we usually use the suffix amine. So let's have a look at this one. So this is a primary amine. Now it has only one methyl group attached to the nitrogen and two hydrogens. So we will call that methyl amine. Of course, the amine only have one nitrogen. It's just a nitrogen. And because it's the parent name, so we will call it just methylamine. So what about the next one? It's again another primary alcohol, and it's primary amine, and it has the ethyl group here as a substituent, so it will be called ethylamine. This one, it has a propyl, so it's called propylamine. If we have two R groups attached to the nitrogen, then if they are identical, then we will give it the name di. And if they have three groups which are identical, we will give it the name tri. So for example, this first one, it's called diethylamine because we have two ethyl group attached to the nitrogen. Now this is a secondary amine because the nitrogen has two alkyl group and only one hydrogen. So this is a secondary amine. This one here has three different alkyl, not different, it's the same. So three alkyl groups attached to the nitrogen. This is a tertiary amine. And because all the three groups are identical, we will just call it triethylamine. All the three are ethyl. What if the amine has two different groups? Then we will then arrange them again alphabetically. So for example, the first one here is called ethyl methylamine because we have an ethyl group and a methyl group. And when you arrange them alphabetically, the ethyl will come first before methyl. So you simply say ethyl methylamine. This one you have dipropyl, two propyl groups. This is a tertiary amine, two propyl groups, and one ethyl. So, and this is a tertiary amine. So you're going to call this ethyl dipropyl amine. So the parent name here is the amine, and then you will mention the ethyl first before the propyl. Ignore the di when you arrange the alphabetical, okay? But you have to say it in the name. So it's going to be ethyl dipropyl amine. We don't call it dipropyl ethyl. We call it ethyl dipropyl because we arrange them alphabetically. Something like this one, this is a secondary amine. We have a methyl group and we have a phenyl group. So to arrange them alphabetically, it's going to be methyl phenyl amine. This one, it has two phenyl and it has a methyl. Again, the methyl will be mentioned first and then diphenylamine. This is a tertiary amine. So if we have other functional group in the name and the amine itself is not the main functional group. For example, if we have a carboxylic acid group. If we have a carboxylic acid group, usually the carboxylic acid is the parent name or is the parent or is the root name for our compound, and then instead of the compound will not be said as amine, but we will consider the group as the amino group as a group as a substituent, and we will call it amino. For example, if we have something like this one, so this is an ethanoic acid. This is the parent name. Ethanoic acid, this is carbon number 1 and this is carbon number 2, and then we have the amine group, so it's will be called 2-amino ethanoic acid. something like this one. This is propanoic acid. Again, always start with the carbon that will give the functional group the lowest number. So this is 1, 2, 3. So this is 3-amino propanoic acid. Now this compound, because it has 2 amino group, so none of them will be considered separately as the main functional group, but we will consider both of them as amino groups. So we will give the parent name to the alkane, the longest chain of alkanes, and we will number it to give the amino group the smallest possible number, 1, 2, 3, 4, and 5. So it's a pentane. So this is going to be the root name. And then we're going to say where are the 2 amino groups are. They are on carbon number 1 and carbon number 2. So this is called 1,2-diaminopentane. So when you consider the amino group as a substituent, then you have to number your longest chain of alkane, where you give the substituent the smallest number, unless you have something that is given priority, like we said here with the acids. So with the acids, always the carbon that has the functional group here will be given number 1 for a carboxylic acid. So in this case, we cannot name it 1-amino to ethanoic acid. No, we have to give priority here to the carboxylic acid group. So always the thing that we have been always talking about when you give the number, when you number the long chain of alkane, that you always give it, number it from the side which will give the substituent the lowest